In engineering mechanics, all physical quantities can be described, can be completely specified either by its magnitude or by a combination of magnitude and direction. So you will need either magnitude or a combination of magnitude and direction for describing all physical quantities in engineering mechanics. Those physical quantities that are completely specified by magnitude only are called scalars. And those that are completely specified by magnitude and direction are called vectors. So, scalars and vectors. It's a bit difficult to always distinguish between scalar and vector. I'll give you a simple technique so that you can remember which is scalar and which is vector, or that will help you distinguish between these two. Scalar starts with S, vector starts with V. So S for scalar, V for vector. And if you consider the English alphabet, S, T, U, V, and considering scalar and vector, S comes first ahead of V, which is coming second if you consider S and V. So in the English alphabet, S for scalar comes at number 1 and V for vector comes at number 2 if you consider scalar and vector only. So scalar can be described by a single parameter, that is magnitude, and vector can be completely specified by two parameters, that is magnitude and direction. I hope this helps. S for scalar, V for vector. In the alphabetic order, S comes first and V comes second. So S uses one parameter, that is magnitude, for a complete description, whereas V for vector uses two parameters for a complete description, that is magnitude and direction. So if you understand this, you will never forget, or you can anytime you can remember which is scalar and which is vector. So what are the examples for scalar and vector? You draw a line say you draw a line and call it length, having a length of maybe say 40. Now that is a scalar quantity because it's only a length. If you measure from here to here, say A to B, if you measure A to B or B to A, it's the same. But the same length or a similar length that is again shown as a length, but here you say this is a force acting on a body in this direction. So it's a body of mass m and there is a force F acting on that body which has got a magnitude of 110 Newton and a direction or a sense in this way. So now that you have a magnitude and a direction. You have a magnitude of 110 Newton and a direction or sense. So the angle that the vector makes with the reference axis is its direction. Say theta. You can also specify the angle here. That depends on where your reference axis is. So if you are taking the reference axis from here, you can also specify the angle here as well. That depends. That depends where you specify actually where your reference angle is. In this case, both thetas are same, but there can be differences. So to simplify, if you draw a line showing a force, and suppose your reference line is here, then the angle you have got a force in this direction, say F equal to 100 Newton, and that is your angle. That depends which is your reference angle. So this is a vector because it has got a magnitude and a direction. This is its direction or line of action for in terms of forces. So scalars and vectors. S for scalar, V for vector. Scalar needs one quantity, that is magnitude, for a complete description, whereas vector needs two quantities, that is magnitude and direction, for a complete description. Length is an example of scalar. Mass is an example of scalar. Time is an example of scalar. And force is an example of vector. It have to have a magnitude and a direction or line of action.